All right, question number 13. We have another application. It says a ball is thrown vertically upward from top of a building 128 feet tall with an initial velocity of 112 feet per second. The distance s in feet of the ball from the ground after t seconds is s equals 128 plus 112t minus 16t squared. After how many seconds does the ball strike the ground? Okay, so you can draw a picture of what's going on, but usually with these word problems and applications, they pretty much give you everything that you need to solve the problem. So I'm just going to kind of give you a visual of what's going on. So we have, let's just say, a building here, and we'll call this the ground. This will be the ground. All right, so we got some person on top of a building, little stick person, and they're throwing up a ball. Let's say the ball is here. So it's thrown upward. So it's going to go up, and then it's going to start coming down, and it's going to hit the ground. All right. We're given this equation, S, and they told us S stands for distance. S is equal 128 plus 112t minus 16t squared. And we're told t is time in seconds. And we want to know, when does this ball hit the ground? Well, when the ball hit the ground, it will be at a height of 0. So the distance from the ground, because S is distance in feet, the ball is from the ground. So when the ball is actually on the ground, it will be at a height of 0. So basically, we're just dealing with another quadratic equation. 128 plus 112t minus 16t. We can rewrite it 16t squared so that the t squared term is in front, which I guess I will go ahead and do that. So I'll write 0 equals negative 16t squared plus 112t plus 128. All right, so first I want to see if this factors. Factoring is the easiest method to solve quadratics. When you factor, this needs to be positive. So I want to check to see if each term is divisible by something to make this smaller to begin with. So I am just going to pull up this basic calculator, and if it would be nice if they're divisible by 16. So I'm going to try to divide each of these terms by 16. So 112 divided by 16 is 7. And what if I do 128 divided by 16? Gives me 8. Okay, so I am going to factor out a negative 16 to start this problem, because factoring needs to have a positive in the front. Always remember that. So we have 0 equals, I'm going to pull out negative 16. All right, and then when I divide, this becomes t squared. So 16 divided by 16 is 1, so just 1t squared. When I divide a positive by a negative, the sign changes. So this will become, I can say plus negative 7, or I can just write minus 7, but since I've already put the plus, say minus a negative, plus a negative 7t, and then it'll be minus 8. So I could put plus negative 8 or just minus 8. So here, now my problem has been significantly reduced, and this is the one that we're going to factor. Let me move this out of the way, and then I've checked. All right, so I'm going to factor. So once you factor out a common factor, that 16 just stays on the outside, and we're factoring this part on the inside. So I'm going to multiply 1 times 8. That gives me 8. And I'm looking for the factors of 8 that subtract to give me 7. That will be 1 and 8. All right, so this will factor. 0 equals negative 16. And then 2 sets of parentheses we're going to distribute and put a t in each of them. That's our variable this time, t. At the back, we're going to pick 1 and 8, and then follow the rules of signs. So I wrote plus, but this actually is a -7. So I think about this as -7, so you don't get confused on the rule of signs. The first sign is the larger number, so this will be a negative. Second sign is negative, means they're different, so this will be a positive. Alright, and then from here we set each of these factors equal to 0. So this is one factor and this is another factor. So I have 0 equals -16, and then t plus 1, and then I have 0 equals t minus 8. I don't need parentheses here. Alright, so we would divide by 16, or divide by -16. Alright, so that goes to 1. Anything divided by itself is 1, so that leaves us with 0 divided by -16, which is 0. So then we just have 0 equals t plus 1. And then we can solve it. So subtract 1, we get -1 equals t. So be mindful, this is a real world problem. T is time, and there's no such thing as a -second. So this will not work. We will throw that answer out. When we solve this one, we would add 8. So 8 equals t. So this ball will hit the ground in 8 seconds. So that's what we get here. So after 8 seconds, and now we have another part. So part 2 says, after how many seconds will the ball pass the top of the building on its way down? So we want to know, when is the ball back at its original starting point? So we were at the top of the building. We want to know when it's right back even at 128 feet. Okay, so we want to know, we're going to do the same thing. We're just going to set, instead of setting the equation equal to 0, we're going to set it equal to 128. We want to know when it's at the same height. So I'm out of space on this paper, so I'm going to start another one. So the equation that we had, I'm going to say S equals 128 plus 112t minus 16t. And we want the height this time to be 128. So 128 equals 128 plus 112t minus 16t. Alright, so we're going to start by moving the 128 over, because we want this side to be equal to 0. Minus 128. So doing so, this goes, the left side is 0, that goes to 0, and we're just left with 112t minus 16. Shit, I forgot my squared, t squared. That'd be very important. Alright, so from here, we're just going to factor on this side. So both of these terms are divisible by 16, and they both have a t. I'm going to do the negative because I want this to be positive. So 0 equals, I'm going to factor out a -16t. So I'm dividing both terms by -16t. Same thing, this is just a -7. This will be a positive t. Now, when we go to solve these, we set both of these terms equal to 0. So I have a 0 equals -16t, and then we have 0 equals -7 plus t. Alright, so divide by -16, we get 0 equals t, and then solving this one, we get 7 equals t. So there's 2 times when this ball is at 128 feet. One is when we first have it in our hand. Okay, we start at 128 feet, we throw it up, and it starts coming back down. On its way down, this is the time when it's passing 128 on its way down. And that's what the question says. After how many seconds will the ball pass the top of the building on its way down? So it's the later time that we're looking at, which will be 7 seconds. So based on my drawing, looks like this ball covers a huge distance. Maybe you threw it way up and then it started to come down, and so maybe my drawing doesn't really fit the problem scenario. But 7 seconds is when it hits 128 on its way down.